proofs involve CPCTC in them, which means that it takes them beyond just showing that triangles are congruent into actually using your congruent triangles to say something more about the picture. So they want us to complete this proof. They have the statements filled in, but the reasons are blank. They gave us two pieces of given information. The first one is marked in the picture. The second one has a vocabulary term in it, so they didn't get to mark in the picture yet. But yx is congruent to wx is marked in the picture. Then they said that zx bisects angle yxw, which is this angle up at the top, the large angle at the top. Zx bisects that. Remember that a bisector cuts it equally in half. So I'm going to mark these sides of this angle congruent because they are being bisected. I'm going to continue to look at the picture before I get into my proof just to see if I know how to get to the thing I want to prove. I'm trying to prove that YZ is congruent to WZ. So if I'm able to say the large triangle on the right is congruent to the large triangle on the left, then I would be able to say that. I do notice that these triangles are touching and they share this side down the middle here. XZ is shared, so I'm going to mark that with 2 marks as being congruent to itself, and then I'll have to use that in the proof and put reflexive property. But then I'll be able to say that the triangles are congruent. I've got 2 sides and the angle in the middle, so that's side, angle, side, for the reason that they're congruent triangles. And then I'll be able to say that the last pieces that they want are congruent by CPCTC. So now we've thought through it all and we just need to put it into the proof. So the first thing that was given is this first line of the proof, and so we write given. The second thing is on the second line, so that's given as well. These angles that they named are the angles up at the top that we marked, and we marked them because we knew that a bisector bisects an angle into 2 congruent parts. So we were using the definition of an angle bisector. Anytime there's vocabulary, generally the line right after it uses the reason, that the definition of it, because we use that definition to get the next statement. Then they said XZ congruent to XZ, which is what we were saying about the shared piece in the middle. That's that reflexive property. And then the triangles are congruent now by side, angle, side. And we're able to say this statement about the other sides of it by corresponding parts of congruent triangles are congruent. And if you forget these letters, you could try to write out the corresponding parts of congruent triangles are congruent. If you're not able to come up with the letters, sometimes you can come up with most of those words to sort of get the gist of what you're trying to say. The next proof on the page is blank. We're supposed to prove UV is congruent to WX. Anything that's already marked we're going to go with as a given information. So I'm going to write those things in that are marked as though they're given on the first line. So I'm going to say that VW is parallel to UX given. Now, I'm not going to write in the other given yet. I'm going to wait on that for a minute because I'm going to use these parallel lines, and I think that it's going to make more sense if I use them right after I listed them. So remember that parallel lines, they always lead to congruent angles. So I'm going to sort of highlight the transversal and the parallel lines, and you can see the Z shape. So these are alternate interiors, and we're going to have this angle at W up here congruent to this one here at U. So, and I'm going to have to name it with 3 letters because there's more than one angle there. So I'm going to say angle VWU congruent to angle XUW. And the reason is the alternate interior angles theorem. So now I've got one set of angles. Now I'm going to list my right angles that are marked, because that's like a given. So angle VUW and angle XWU are right angles because they were marked as being right angles. So all we're going to say is that we were given that they were right angles. So that was a given statement. Now, we didn't say they're congruent. And unless we're using it for HL, if you're using the HL as your reason in your proof, then you don't need to say that they're congruent. You just need to say the triangles are right triangles. But here, I'm not going to go for HL. I've already kind of looked at my picture, and I can see that I'm going to have two angles and that they share the side here that's between. So I know it's going to be angle, side, angle. So I need to use my right angles and say that they're congruent. So my fourth reason here is going to be that these, or my statement, is that these angles are congruent. And I know that for you, you're like, that's so obvious, but you need to write it into the proof. And the reason is that all right angles are congruent. They just always are. So we're going to say, we have to say that in the proof. We have to make everything in the proof really, really obvious. Now, they share this side. These triangles are touching. They share the side. There's no congruent side markings. Remember that parallel line markings do not mean that those sides are marked. So we need to mark this side that they share in the middle here, and we need to add that to the proof. So UW is congruent to UW, and the reason is the reflexive property. And now we're able to say that the triangles are congruent, so I need to name them. I'm going to say VWU. V had no marking, so over here I need to start with no marking, which is X. W in the top triangle had one mark, so I need to go to U in the bottom triangle that has the same marking. And then the last one I named, in the first one up top had a right angle, so the last one needs to be the one with a right angle on the bottom. And my reason is angle, side, angle, because it's two angles marked in the side in between. And now I'm able to make the last statement that they were wanting, which is that UV is congruent to WX by CPCTC for the reason there. And that proof is done. So my last proof in the notes is this one, not a bad one. I've got the bow tie picture. I'm going to have my vertical angles here in the middle. That's all I'm going to need in addition to my given to say my triangles are congruent, and then I'll use CPCTC to say the statement they want me to say. So I'm going to start with my given. I'm going to start with my segments. Really doesn't matter. QP congruent to PT. Given, because it was already marked. 2 is that angle U is congruent to angle S. That was given. And 3, I'm going to start naming my vertical angles. Remember, there's more than one here, so we need to use 3 letters. I'm going to say QPU. So QPU TPS. The reason vertical angles congruent. On naming these angles, as long as P is in the middle, the other 2 letters could be switched. It would still be okay. But when you name the triangles, that's where it's really important to be careful of the order. So I've got one side and 2 angles, and notice that the side is not between them, so it's going to be angle, angle, side with the S on the end for my reason, and I need to name my triangles. I'm going to go 1, 2, none. 1, 2, none on my marking for my naming, just to make sure I go in the right order. So I'm going to go UPQ. Again, however you name the first, you just match that order. So I want UPQ, so I need to go SPT. Sorry, that's my refrigerator. And the reason, again, angle, angle, side. And now we're able to say the final statement of the proof, which is that ST is congruent to UQ by CPCTC. And that is it.